So our second day of our little mini unit on stats, we're going to be talking about different ways you can represent your data with different types of graphs. So we're going to talk about bar graphs, histograms, stem and leaves, and box and whiskers, and using those graphs to answer questions about the data. So let's take a look at bar graphs versus histograms. And I would say most people would look at these and say they're all bar graphs. So how can you tell what's different in a bar graph versus a histogram? Well, if you look at these really closely, they both have 30 students, and here's how I can tell. This looks like it might be like 7 students, okay, but that is actually the frequency was only 1. And so that's saying there was one kid who had 7 siblings, okay? So if you want to see how many total there are, you have to look at the frequencies. There was 2 of them that had 1 of them that had 2, one of them that had 3 people had 3 siblings. That one's confusing. This one, 8 people had 2 siblings. 10 people had 1 sibling, and then 5 people had no siblings. They were only children, so to speak. All right, so that's how you can tell that one adds up to 30. Versus this other one, it's the same idea. The frequency, how many there are, is still along the left-hand side, so I won't torture you with adding those all up. But there's 30 in both instances. So how can you tell that one of them's a bar graph versus one of them's a histogram? In histogram, sometimes they describe this as a bin, and between 0 and 5, if you have between 0 and 5 minutes to get to school, then there would be 3 kids that had between 0 and 5. Okay, so that's like a category. It's not as good in a way because you can't tell if, 2 people were only, 1 minute away from school, and then another person was exactly 4.8 minutes away from school. You can't tell, but 3 people were in that category. Okay, so if it's got categories along the bottom like this, like little bins, little ranges of numbers, that is a histogram. There's other ways to make histograms too, but all right, let's talk more about these 3 questions. How many students have 7 siblings? The one that's about siblings is this one. And 7 siblings, that was 1 person had 7 siblings. That was this one again. And how many students take 7 minutes to get to school? That is over here under minutes to get to school. And 7 minutes. See, this is what I was saying about how these are not awesome because you can't tell exactly how many students take 7 minutes to get to school because that's in the bin. 7 is in between 5 and 10. All I could tell you for sure is that 9 students take between 5 and 10 minutes to get to school. So we can't really answer that question, okay? But we can say that 9 kids take between 5 and 10 minutes. All right, let's move on. Now comparing a histogram to a stem and leaf plot. These don't look very similar, but they do have the exact same data on it. All right, and a histogram, remember this, the kind that has the bins on the bottom. We just discussed those. Compared to the stem and leaf, look at the key on the stem and leaf, and that tells you a lot. It says that 2/3 means 23. Okay, so this right here, for example, that means 63. That means one of your data points was 63. That would have been this one, between 60 and 70. And there was only one of them, so the frequency would be 1. All right. Which one's better? Well, depends on what you want. This one's a little more visually appealing maybe because it's got different colors and you can see the bars and you can, get different clumps of the data. But this one's also pretty cool because you know all of the exact data. If you only had this, you would know that 12 kids have between 0 and 10 minutes to get to school. But this one tells you exactly how long each person's commute is. And that's better in a way. Okay? So let's answer a few questions. How many students take 7 minutes to get to school? Well, I can't tell from this one, but I can tell from this one. 2 kids, see, take 7 minutes to get to school. And I could tell from the stem and leaf plot. What's the median amount of time, that's also known as the middle, it takes these students to get to school? Well, again, the stem and leaf plot's going to be the better way to go. In this case, there are actually 29 students. I counted it twice because I thought there was a chance that I was missing the 30th one, but nope, there's 29 students for sure. And maybe the reason that the author chose 29 students to work with is that there would be one that's exactly in the middle. Because see, if you had 30 students, there'd be a tie between two of the numbers. By the way, when that happens, you just average those two that are in the middle. But, all right, so I'm going to just say if there are 29, then I can say that the 15th one would be exactly in the middle. So this would be 0, 2, meaning 2. This would be the number 0, 4, which means 4. This is another 4. And I'm just going to count up and get the 15th number. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the 15th number, and it's not a 1. It's a 1, 1, meaning 11. So 11 was the one in the middle. Now, if I want to be really sure, I can count back from the other way. 63 was my biggest number. That's one number. Second number. Third number. Fourth number. Fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13th, 14th. Once again, it's the 15th number. So yay, 11 has got to be the middle number, the median amount of time that it takes to get to school. All right. Now let's talk about scores from a freshman basketball team. So this is different amounts of points that they scored. It's kind of set up in a weird way because you sort of feel like these are being paired together, but they're really not. This just happens to be a bunch of different separate scores from how many points they scored in a game, okay? And because there's no other labeling, we can't assume there was another team involved. This just must mean all of the different times they played a game during the year, they wrote down how many points they scored, okay? Now, if you're going to make a bar graph, I'm just going to start these because these videos are meant to be quick during the quarantine time. So if you're going to make a bar graph, your frequency goes on the left side and like how many times that happened goes on that side. And then along the bottom, if this had been a histogram, we'd have like the different bins. But down here, we would make all the different scores that could have happened. We would have put them in order from smallest to biggest. And then we could make a little bar and see how many times that happened. Okay, if we were going to do a stem and leaf, so basically it would look kind of like this. All right, in the stem and leaf, if you're going to do a stem and leaf for it, that one's actually easier to construct by a long shot. So I'll just get that one started. Did we have any 0-point games? Because if so, it would have looked like this. We didn't even have any single-digit point games, which is good for a basketball team. So then if I put a 1 here, and the lowest number that I see up here is a 12. And so that would represent my 12-point game. Okay? And then let's just pick another one. It may not necessarily be the next smallest one. I think the 16 is the next smallest one. So then I'm going to put a 6 here. Notice I don't put any comma in between them. You just have to know when you're reading it that that means 12 and 16. And then let's look for the biggest amount of points that they scored. Upon a quick look, it looks like 48 was the most that they ever scored right here. And so that would be down here, 2 30s, 40s, and then an 8. So 48 was the most they ever scored. They did have a 41, so I'll put that in. And they had a 42, and then they had a 48. Oop, I just saw 51. Haha. So then here's 50 and a 1. 51 was our largest. So this does not have all my data in it, trying to save time. But if you wanted to make a key, just like on our other one, we could say 5/1 equals 51 to show people how to read this graph. Okay, all right. Let's talk about the box and whisker. This one's already done a box and whisker for this data set here. And it takes this 5-number summary and takes the 5 numbers and puts them all on a nice little plot. So our lowest number goes here on the end of the whisker. That's our minimum. The next one is the Q1. That's the middle of the lower half of the data. So here's the middle, the median, and this is in the middle of the lower half. That's what Q1 really is. Q3 here is in the middle of the upper half of the data. See, it kind of like cuts that in half. All right, and then our fifth of the 5-number summary is the maximum. In this case, that was 42. See right there. Okay, so the whole box in the box and whisker is the middle part, and that is the middle 50% of our data points. So the middle half. This is the upper 25%. This is the lower 25%. And really, because they're called quartiles, they're dividing it into 4 25% of the data chunks. Okay. And remember, the middle of the whole thing right here, the median, is also cut up into halves where the Q1 is the middle of the lower half and the Q3 is in the middle of the upper half. So that's how a box and whisker works. Now, if we're going to consider this data set and draw the 5-number summary for the data, guess how I did that? I put it in my calculator under Stat, Edit, and once I had the data in the list, I went to Stat, Calculate, one variable stats, I hit Enter, and here's my 5-number summary that comes up. Now, if I'm going to make my box plot, I just need a whiskers and I need a box. And if you're really going to be super accurate, you would number a number line underneath it like you saw on our last one. Okay, I'm going to be doing this quicker, so I'm not going to try to construct that all perfectly, but I'm going to put in my 5 numbers for sure. Here's a 2 on the low end. Here's a 9 on the high end. Our Q1 is at 2.5. Our Q3 is at 6. And our median is at 5. As you all know, 5 is really close to 6. So don't think that this middle line has to go right in the middle of the box. It doesn't. It's proportional to, try to make it close to the number it's closer to. So, all right, so there is our box. That means that 50% of our data is between here and here, and that's the middle 50%. This is our top 25% right here between 6 and 9, and between 2 and 2.5 is our lower 25% of the data. Okay, so what's the range? Yes, for the range, that's 9 minus the 2 is 7. What's the interquartile range? That's the 6 minus the 2.5, which would be 3.5. And now it asks for the percentage of data values that are less than 3. All right, so I'm going to find things that are less than 3. All right, well, here's our things that are less than 3. 1, 2, 3 things are less than 3. So 3 out of the 16 data points are less than 3. Now, if they would have wanted to say less than or equal to 3, that would have totally changed it because there was a couple of actual 3s in the data. But if it's 3 out of 16, that is your percentage of the data, which if you divide on a calculator, that's 0.1875, about 19% of your data is less than 3. I think that's not an awesome follow-up question. I would have asked something about what is the lower 25th percentile of your data? And then you would have been talking about our lower quarter of our data is between 2 and 2.5. So, all right, moving on. Once again, to try to keep these videos brief, I'm not going to construct the whole bar graph for this data set, but you would remember to put the frequency, like how often the thing appears, along this side, and then on the bottom you would put your different numbers. So the smallest number that we have is a 2, and then we have some 3s, then we have some 4s, 5s, 6s, 7s, 8s, and 9s, since these are all single-digit numbers. And then you just put a bar for how many there are. Okay, so for instance, for the 2, there was 1, 2, 3, 4 2s, and so we'd go up, say there were 4 2s, and our bar would go like that. And that would be really tedious to watch me make that whole bar graph, so we'll move on. All right. 2 groups of students were surveyed regarding the number of books they read over the summer. The results are shown in the graphs below. Right away, I can see there's a difference between these two. In Group B, it went from 9 to 2 books read versus 8 to 2. Is that a big difference? No, it's not a big difference. But if I look at the middle part of the data, the middle part here goes between 3 and 5 books, and here it goes between 3 and 6 books. Everything on that Group B is just a little higher, like it's stretched a little bit higher. All right, and we have a bigger interquartile range. Here we only have an interquartile range of 2, so the data is a little more tight together. And here we have an interquartile range of 3, 6 minus the 3. And so there's a bigger range on Group B, and generally they, as a group, read more books. All right, on average, did the students in Group A or B read more over the summer, as I described, Group B? And if to be exact, I'd need to take all the data points and figure out on average. It's difficult to find the average here. We can find the median. The median is 4, but again, kind of a bad question because you can't get an average unless you have the raw data, but you can get the median. The median was 4 in both cases. All right, so again, depends on how you define average, but most people would have called that the median. All right, does the following bar graph represent Group A or B? And the way you can tell is that this one maxes out at 8. The number of books read is 8, whereas these guys, the max was 9. Okay, I better erase this so you can see it better, but there's a 9 there. So this had to be from Group A because of looking at that max. All right. Hope you feel like you've learned a little something about how to display your data and different types of graphs and how to read them. Especially the most important ones, I would say, are the stem and leaf and the box plot. Have a great day.